Friends, this question was asked in the year 2010 in an examination from in chapter Units and Dimensions. If the energy E is equal to G to the power P, S to the power Q, C to the power R, where G is universal gravitational constant, H is Planck's constant, and C is velocity of light, we have to find out the values of P, Q, and R. Okay, student? But before that, we have to find out the dimensional formula for universal gravitational constant G, Planck's constant H, and velocity of light C. Okay, students? Newton's, we have studied Newton's universal law of gravitation. This law states that, student, if there are two forces m1 and m2 placed at a distance r from each other, then the force, gravitational force of attraction between these two bodies of mass m1 and m2 will be equal to g m1 m2 by r square. That will be directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And g is the proportionally constant called Newton's universal gravitational constant. Okay, student, from this equation we get a formula for G. What is G? G becomes F square by M1, M2. So the dimensional formula for G will be equal to dimensions of F square divided by dimensions of M1, M2. And we know what is the dimensions of for student, that is MLT minus 2 and R square, L square, M1 M2 means M into M. Okay, student, this M cancels out and this becomes M to the power minus 1, L3, T to the power minus 2. Let us write it here. G is equal to M minus 1, L3, G, T minus 2. Let us clear the whiteboard to find out the formula for Planck's constant H. Students, the energy of a radiation is directly proportional to its frequency. So E is equal to h nu, where h is the proportionality constant called the Planck's constant. Students, from this equation E is equal to h nu. E stands for energy, h is Planck's constant, nu is frequency. We can get the expression for h as h is equal to E by nu. So dimensions of Planck's constant H will be dimensions of energy upon dimensions of frequency. What is the dimensions of energy, student? All forms of energy have dimensions ml2 t minus 2, and frequency is the number of oscillations per second or the number of vibrations per second, and its formula is nu is equal to 1 by t. So its dimensions is t to the power minus 1. So this becomes, student, ml2 t to the power minus 1. So let us write it here. H has dimensions ml2 t minus 1. Okay, student. Next, let us learn the dimension of velocity of light. What will be the dimensional formula for velocity of light, student? Velocity of light is also a velocity, and we know the dimensions of velocity, that is displacement upon time. So the dimensional formula is Lt minus 1. Let us write the equation given. Energy E is equal to G to the power P, H to the power Q, C to the power R. So students, that is N minus 1, L3, T to the power minus 2 to the power P. H is ml2 t minus 1 to the power Q, and this will be L t minus 1 to the power R. Okay, student. Then let us expand this equation. This will be m to the power minus p, L to the power 3p, t to the power minus 2p, m to the power q, L to the power 2q, t to the power minus q, L to the power r, e to the power minus r. Okay, students, Then let us write m to the power minus p plus q. Okay. Then L to the power 3p, L to the power 2q, L to the power r. So t to the power minus 2p, t to the power minus q, t to the power minus r. Okay, student? On expansion we get this thing, and the dimensions of mass, length and time must be equal to the dimension of the left hand side. What is in the left hand side? That is energy, and we know the dimensions of energy, student, ml2 p minus 2, or we can also write m1l2 p minus 2. What is the dimensions of mass here? 1. Here minus p plus q. So minus p plus q is equal to 1. This is equation 1. 3p, L has dimension 3p plus 2q plus r. So student, 3p plus 2q plus r is equal to how much? 2. And this is equation 2. And equation 3 is minus 2p minus q minus r. The dimension of t, and the dimension of t in the left hand side is, student, that is minus 2. So minus 2p minus q minus r is minus 2. Let us write it here. Minus 2p minus q minus r is equal to minus 2. So let us add this. This r cancels out. 3p minus 2p is p, and 2q minus q is plus q. 2p plus q is equal to 0. Okay, student? In adding equation 2 and 3, we got this. We write it here, p plus q is equal to 0. So student, on adding these two equations, p minus p cancels out, twice q is equal to 1. So q is equal to, students, half. And what is p? P plus q is equal to 0. We have obtained the relation p plus q is equal to 0, or p is equal to minus q. So minus, what is q? Q is half, so p is minus half. And what is r, student? R is 3p plus 2q plus r is equal to 2, or r is equal to 2 minus 3p minus 2q is equal to 2 minus 3. What is p? P is minus half. We write it here, and minus 2q means minus 2 into q. What is q? Q is half. We write it here. So this becomes 2. This minus minus become plus, and this is 3 by 2, student, and minus 2 cancels out. This becomes minus 1. So 1 plus 3 by 2 is equal to 5 by 2. So r is 5 by 2, p is minus 1 by 2, q is equal to 1 by 2. Minus 1 by 2, 1 by 2, 5 by 2. So option A is correct, students.